Anyway, I'm Dr. Vinitha PG, Assistant Professor at CSM Thiruvarukunda, acting as co-chair for the session. To start with, we have got a very renowned scientist, Dr. Veerasamy Sejian from NIANP, Bangalore, to deliver a lead paper on climate change and poultry production, impact and amelioration. And the session is chaired by Professor Dr. G. Girish Verma, Dean, Faculty of Poultry Science, and Dean of College of Avian Sciences and Management, and also acting as Principal Investigator of NAHEP project. I invite Dr. Girish Verma to introduce and welcome Dr. Sejian to the session. Over to you, sir.
This morning, I am very happy and proud to introduce our speaker, Dr. Veerasamy Sejian. He is much younger to me, but he is a teacher to me who has inspired me to the wonderful world of livestock and climate change scenario. And I have been trained under Dr. Sejian at Rajasthan, CWRI. And after that, we had a common path together for several occasions and several issues and projects. And let me introduce Dr. Veerasamy Sejian, who is a well-known scientific personality in the area of climate change and livestock production. He has handled 12 research projects, and out of them, 7 major products are in the area of climate change and livestock production. Dr. Sejian is working as senior scientist in National Institute of Animal Nutrition and Physiology, NIANP, Bangalore. He has published around 139 research articles. By now, it might have gone beyond that, I know. Authored 3 books and 87 book chapters, and presented 256 lead papers. Again, much more than being reported here. Also, he has mentored 14 students and 2 postdoctoral researchers, and he's a member in many professional associations and editorial member of around 27 international journals, international reputed journals. He is a recipient of several honors and awards, like D.N. Malik Memorial Award for the outstanding contribution in the field of animal physiology, Australian Government Endeavour Research Fellowship, Faculty Research Award 2018 by Careers 360, as one among the top most outstanding researchers in the field of environmental sciences category, Lal Bahadur Shastri Outstanding Young Scientist Award 2012 by Indian Council of Agriculture Research. And these are just a few. And I'm very happy to introduce the speaker, and we will have a very, very active participation from the participants. So just after delivering, we'll go to the discussion session where we'll deal with the major clarifications or opinions. So now I invite Dr. Sejian to start his lecture.
Thank you very much, sir. At the outset, let me first thank Professor Girish. He is one of my mentor, in fact. So, like, he was so magnanimous in saying that he had learned from me. And I know that since 2011, when he visited me at Rajasthan, since then the association has been very strong, and he was an inspiration for me when he opened up CADEX at Kevasu. Okay, thank you so much. Good morning, all the participants, and it's been a new platform to do webinars of this kind, and so like I'm extremely happy that we are on a right platform. In fact, we can see that COVID has a lot of negativity last couple of months, and if you ask me personally, that with these technologies, I think we are taking the world together in no time. So that is what the positivity we need to take from such type of crisis period. So without wasting much time, the topic assigned to me by Professor Girish Verma was climate change and poultry production, impact and amelioration. So like this is what I'm going to target in next 45 to 50 minutes or so that 10 minutes can be allocated for the discussion. This is going to be my plan of talk. I'll introduce what is that the importance of the poultry sector to India and how climate change is related to the poultry production, and why we particularly target heat stress as the major factor influencing poultry production. And there will be different approaches I would project to the audience for the heat stress amelioration, and also some managemental strategies, some nutritional intervention point of view, and most importantly, the breeding strategy, how to cope the birds to the heat stress condition in particular, with some sort of conclusion and future projection. And before I actually start, so like coming to the theme of the conference, like there is a world around buzz going around that myth about chicken meat, whether we can consume in the COVID-19 pandemic. The answer is we can, 100 out of 100 times. So like there should not be any misconcept about that. And all of us are very learned experts, and we have been witnessing what is happening last 4 months or so in the pandemic COVID-19. So we know that very well. Different bodies have come together and pooled data, and they've concretely told that the pathogen do not transmit through the food particles or food materials, so it is very safe. Only that certain precautions, as it is very important, since it is a zoonotic disease, some be taken properly for that. That is what it is. So we can see that almost due to the fake news transmitted in India, it is almost estimated that 1.6 billion a day loss in the poultry industry have been projected. These are all some of the newspaper cuttings I have taken, and also our honorable Agriculture Minister himself have told that Dr. Veerasamy Singh had told that almost India is losing around 1,500 to 2,000 crore per day as a result of this misconcept, wherein there is a sudden drop in the consumption of meat as well as egg and the other products associated with the poultry. And there is a American biologist who believes that the coronavirus, fear of coronavirus is more than that virus itself. That's what. There is currently no evidence supported by World Health Organization that the virus spreads through food, and it is not the route of transmission. That's what they promote to us. And so what are those precautions that we need to take now? And this is what it is. COVID-19 infection is not linked to specific food. People can eat properly cooked chicken and as well as the vegetarian food as per our ICAR guideline. And also World Health Organization suggests that COVID-19 virus is not more resistant to heat. This is also a very important point to be noted. So virtually they are all recommending some sort of good hygienic practices which can be get in what I have mentioned there. And then Indian style of cooking, predominantly coming to our style of living, is very, very efficient in neutralizing most of the pathogens as it is based on moist heat treatment. It is advisable to properly cook the food of animal origin, especially before consumption. Cooking the food for at least 1 or 20 minutes over 80 degrees centigrade is highly recommended. So 4 key steps we need to keep in mind to avoid the COVID spreading through our food materials is that clean your hands and the cooking area in particular. To prevent cross contamination, always use separate utensils for the raw meat, any seafood for that matter, and clean and cut them separately. Don't bring it and mix it with the other things. And also cook at the right temperature as specified for each specific meat, which could nullify. Usually I have already projected that it is 70 degrees centigrade at least. Usually our cooking goes by 100 degrees centigrade, so it should not be a cause of worry at all for India. And also if you wanted to refrigerate the meat, you should refrigerate immediately, not keeping it outside for some time and then doing it. And it should not stay particularly for more hours, so that the virus gets spread if at all the meat is infected. So this is very, very vital. If you follow this, there are no any report at all that it spreads through the food particles. So quite knowingly, we are learned experts, and almost all the poultry specialists must be watching this webinar, and we need to propagate to our near and dear ones that it is very, very safe to consume meat and meat products. Okay, going to my subject proper. I could wanted to promote some sort of the natural calamities. You can see that tsunami in the year 2004. It has washed the entire coastal area of Tamil Nadu, and this is the typhoon at Philippines, which has killed almost 12,000 people in about an hour. And this is a scenario prevailed there. And if you're a North Indian, you would have not forgotten these pictures, which is Uttarakhand in the year 2013. And You can see it is a Nepal earthquake. It is in 2015. Again, an important natural calamity, and it is the 2015 Chennai flood. And you would have never forgotten. And I also missed the Kerala flood last year. So, like a couple of photographs were there, I could not. So like we know that entire state of Kerala suffered hugely for the in 2018 for the Kerala flood. So all these are happening pretty thick and fast. If you can see that in last couple of years, these events, these natural calamities are happening thick and fast. It was not the case. Of course, it do happen a certain part of time, but then it is not in increased frequency as it is happening currently. So it is very important to have some sort of scientific study moving towards to link it with the climate change. The scientific fraternity is promoting, projecting that these are all directly linked with the climate change. These are all the sequel of events that happens as a result of the climate change. And some facts about the climate change, like do you know that around 262 million people are found for the devastating effects of the climate change, and quite alarmingly 98% of such population are from the developing part of the world, principally because we don't have good preparatory system in place. So like we don't have good prediction system which could give us an early warning to tackle the situation. That's why the casualties are more as far as the developing part of the world are concerned. And also as a result of reduction in agricultural production as a result of climate change, 30 million people are likely to go hunger every year. Also, World Health Organization projects that around 150,000 lives are already being lost each year. That everyone, each part of the world are asked to sign the climate bill, which has happened in 2016 in the Paris summit. And these are the, the parameters of the weather. Parameters of the climate. You can call it as like if there is a mismatch among all these variables, then we call them as a climate change. Among these part or the most important culprits are the cloud and the greenhouse gases that are present in the immediate atmosphere. So why it is so? So this is the famously called the greenhouse gas effect. One should understand at the start before I go into the details. Greenhouse gas effect is very vital for all the ecosystem to survive on the earth. So which means, so like what is the problem with the greenhouse gas effect is that with an increased rate of carbon in the atmosphere has made this greenhouse gas effect to be more concentrated, so that all the living ecosystem on the earth is facing the problem. So what it is from the earth, solar radiation hits the earth as an evolutionary adaptive mechanism. Some amount of these hitting rays are to be re-emitted back into the atmosphere. Okay, so what happens is that I told the cloud and the greenhouse gas are the culprits here because they are present in the immediate atmosphere and they trap these reflected rays and they re-emit back. These red lines, you can see the red arrow, they re-emit back to the earth, making the earth relatively a warmer place for all of us to feel the pressure. Well, if there is no greenhouse gas effect, then it would be a cold and uninhabitable place for all of us to survive. That also needs to be stressed upon here. What is happening is that the greenhouse gas effect is happening in an increased concentration, so that the average temperature keeps shooting. As a result of this greenhouse gas and the clouds, they re-emit back to the earth and make the earth a warmer place for all of us to survive. This is what greenhouse gas effect is all about. Intergovernmental Panel on Climate Change. They are the primary body which gathers information across the globe, weather details and the climate details, and then they come up with a projection every 5 years. This is the pictorial representation of the fourth assessment report published in the year 2007, and you can see that average earth temperature distribution pattern across the globe. And you can see that it is somewhere average, if you can claim, it is around 0.8 to 1.1 somewhere overall average if you take. But then quite alarmingly, in next 5 years, the fifth report, you see the grass pictorial representation, how it is happening. So this is very alarming. In a span of 5 years to get this, so like we need to have some sort of good preparatory system in place. This is message we need to draw from this two assessment report of Intergovernmental Panel on Climate Change, the fourth assessment and the fifth assessment report. Well, this is an important data to understand what is climate change. You can see that this is as per the latest IPCC report. I have grouped the average earth temperature from 1860 until 2100. I have drawn a line at 2000, demarcated the world from industrialized era with the pre-industrialized era. And you can see I drawn a blue rectangle there, which says that the average earth temperature from 1860 until 2010 or something, the average earth temperature varied somewhere between 13.5 to 14.5. You cannot claim this as a climate change from 1860 to 2010 because there are a lot of variabilities here. You have to understand that two terms you have to demarcate. One is the climate variability and the another one is the climate change. This 1860 until the rectangle can show 13.5 to 14. There could be several reasons. By natural, there could be a warm year or a cold year. So these all can be called as a variability. But I have drawn a red line, perpendicular line here, where we are in reality here, which cannot be this point, and this point cannot be called as a variability. So something dramatically happening, and these are all concentrated around 2000 when the industrial revolution has taken over, and more carbon have been burnt and then sent back to the atmosphere. This is what the reason for that. So IPCC gathered all the information, and they say that by the end of this century, there is a range of around 2.6 to 4.8 degrees centigrade going to be increase in the average earth temperature, and the central estimate of around 3.7 degrees centigrade. Last 15 years, my research finding, rigorous research finding in various testing conditions clearly indicates that even a 1 degree centigrade increase in upper critical temperature is going to be extremely fatal for livestock survival. So what is that 3.7 degree? In my opinion, as a climate change person, it is very increase which is being projected. There are people who are going to definitely see that it is almost doubling by the end of this century in every possibility. When if the world is not coming and working on a common platform to reduce the carbon emission, this is going further overshooting. This is just a minimal projection according to us. We climate change persons do believe. That's why there are always, in any concept in science, there will be always two school of thinking people. Still, there are people to believe that it is a myth, and people are unnecessarily creating hype that climate change is a buzzword like that. Of course, they are all falling on the first category, where they call the climate change is the natural process. And you know, there is a survey report by the IPCC again, which says that around 98% of the world population have believed that climate is changing. Only that first pathway people are only 2%. So they claim the climate change is quite natural and unavoidable and adaptable and very, very slow. Say, so for example, 0.5 degrees centigrade would have increased in, say, 800 years or 2000 years, 0.5 degree would have increased due to the natural process. But then what is happening now currently, which I have already projected to you, is that it's called as accelerated climate change. It is due to human-made contribution, that is anthropogenic contribution. It is abnormal, very difficult to adapt and avoidable, and is quite rapid now currently. That is why it is a pressing global issue, and people are devoting huge chunk of money for the type of research. Now let me go to the livestock production. What is that climate change is having an impact on the livestock production? It do not contribute to single stress, it contributes to multiple environmental stresses, which can have direct effect as well as the indirect effect. By far, the production losses are incurred as a result of an indirect effect, because predominantly India is a tropical country, and we have very good indigenous which can take care of heat stress quite effectively. But then, of course, both the pathways can definitely culminate in affecting the production, which can cause a severe economic constraint to the country, because we are an agriculture-oriented country, and our major chunk of economy comes from the agriculture and the allied sector. So it's very vital that we need to sustain the livestock production in the climate change. This is a gross pictorial representation from the agriculture point of view, what devastating impact the climate change is having. And you can protection given by the FAO, Food and Agricultural Organization. This is the topmost is the present scenario, and the bottom is the future 2050 scenario. You can see that India falls on the highly vulnerable, because we are having a very growing human population. The world is going to meet by 2050 around 9.6 billion. It is expected, the world population. Where is the source to feed this growing human population? And you can see particularly the African subcontinent and the Indian subcontinent are under highly vulnerable status. This picture clearly indicates that unless or until we have some very good policy making angle determination of what we are going to do, have the future plan to tackle the issue. And livestock is typically one of the highly climate resilient sector which can solve this problem for the future quite easily, because animal proteins are very, very rich, and it is going to serve the purpose for the securing the food security from by 2050. So already they are also vulnerable for the climate change. So therefore the concentration need to be on the livestock sector, because they could provide the solution quite easily to meet the demand of the food for the growing human population by 2050. And this is what it is, that food security, how it is all getting affected. I will not go into the detail. It can affect the food availability, the climate change, it can affect the food access, and it can affect the food utilization as well as the food stability. So all this pathway, the climate change could play an inroad, and obviously this is going to be a biggest challenge, as it is cited in the last part. Reducing the risk to food security from the climate change perspective is going to be one of the major challenges of the 21st century. And this is coming to the subject proper today's discussion. You can see that poultry population, as per the latest livestock census of 1617, it is 648 million tons, and egg production is around 82.93 million eggs from 227 million layers. India ranks third among the countries in egg production in the world, and it ranks fifth among the countries in poultry meat production in the world. The annual per capita availability of egg and chicken meat is 69 and 3.2 kg of meat respectively. The poultry industry suffered major losses in recent past due to the problems of diseases, stress, and feed materials, quality of the feed materials, and all these have culminated in the low production, and this is and also it affected the exports. And you can see it is the egg production statistics. You can see that how India proclaimed itself in the arena of the poultry science. You can see that from 1980 and 1990 decade each interval, how they elevated themselves from the 12th position in 1980 to 6th position, and then 4th position in 2017 it is the third. Meat production also, India maintained the same standard, and currently they are in the ranking of around fifth position in the world for the poultry meat production. Well, you can see that the total meat production in terms of contribution in Indian scenario is a singled out. The poultry sector is a singled out sector in the livestock industry to contribute around 47% almost for the poultry meat production. This shows the significance of the species as comparison to the larger ruminants, or in fact the pig as well. So that this shows that concentrating on the poultry meat is going to be very, very, very enormous for us, because it could give us a clear-cut solution for in the future for getting this. Okay, so let me continue. Thank you so much. And you can see that is what the significance of the poultry meat here I have talked about. And you can see this is the pictorial representation of how the birds are placed, poultry birds are placed to cope to the heat stress condition challenges. For example, there is an arrow. The first two arrows, you can see that they are called thermoneutral zone, where the birds exhibit quite normal behavior, and they can regulate heat stress quite effectively, because they know they have their inherent ability to cope to the heat stress condition when they are within this zone, and that is called as lower critical temperature and the upper critical temperature. What happens in the second mid pathway, which is relatively a bigger one, and it is like where the animals are started to test it in terms of survivability, because they will show initially slow panting, and then there will be fast panting as the curve progresses with the increased ambient temperature, and heat related problem and welfare will emerge in this phase. Of course, this phase is a maximum heat loss happens from the birds. What happens if it is prolonged to the final stage, that is called death from the heat, where the birds can't control their body temperature effectively, which means their thermoregulatory mechanism would fail, obviously, because they are not having any resources further to cope up to the heat stress condition, which will end up in the welfare problem. Ultimately, it may go on culminating in the death of the birds. And this is what the production losses from the birds, especially if you see the production losses would be on this point of view, there will be decreased first the symptom, any animal for that matter, not only the poultry, they show they reduce the feed intake. That is because they don't want to increase their metabolic heat production when already the external environment, the environmental temperature is too high to cope up. So they try to reduce their metabolic heat production by reducing their feed intake, so that they can have a relatively lesser metabolic activity to produce body heat. So which can ultimately culminate on reducing the growth as well as that average daily gain, which is very vital for poultry sector. And as well as it also can be a disruptive force for the reproductive activity, activities, and also it can affect the meat production as well as the egg production in the birds, and finally it may culminate the impairing their immune status also. These are all the pathways by which it happens. First is the voluntary feed intake reduction, then growth, then reproduction, then meat production, then egg production, and then the immune status will be compromised. This is in the order. That's why I have down arrow mentioned in this. And now we can see that these are all the variables when the birds are subjected to the heat stress. These are the sequel of events which happens within the birds. And first and foremost, the physical mechanism wherein they try to cope up by increasing their body temperature. They all can be very good indicators like respiration rate increase, and their pulse rate or heart rate gets affected as well. And then in the blood level, there will be decrease in thyroxine. As I already explained, that metabolic activity need to be at the minimum. So they decrease their metabolic activity controlling hormones. And then also there will be more heat shock protein for countering the stress condition. There will be other blood markers such as corticosterone like that. And then decrease interleukin 2, decrease in TLR, toll-like from the immunological of view as well as the immunoglobulin reduction. These are all the sequelae of event that can happen in the blood, and physiologically there will be increase in erythrophil leukocyte ratio as well as increase in erythrocyte number as well as decrease in hemoglobin, as well as there will be damage to the intestinal mucosa. From the production point of view, as already in the previous slide I explained, there will be reduced feed intake, which can culminate in reduced body weight and lower feed conversion efficiency or ratio, and then also there will be decrease in egg as well as the meat production, and there will be decrease in egg abnormalities as well. So this is the pictorial representation of how the heat stress could affect the reproductive pathway in the birds. It can have a two-way pathway. It can directly act on the hypothalamus, and it can also act via the feed availability. Okay, because they are already reducing their feed intake, and further added to that, if during the summer season, if the feed is not of high quality, then the problem is like they cannot meet the nutrient requirement. Obviously, there will be negative energy balance in the birds, and little amount of feed that is consumed be deviated for life-sustaining activities, because their thermoregulatory mechanisms are very important rather than production. So obviously, both this pathway can affect the gonadotropin-releasing hormone production from the hypothalamus, which in turn can act on the anti-pituitary and reduce the both follicle-stimulating hormone as well as luteinizing hormone. At the ovarian level, there will be decrease in estrogen content, and then there will be decreased oocyte polyp. There will be decreased fertility, and the eggshell thickness will be reduced, as well as egg production will be decreased. Ultimately, it can affect the production. And now moving to for the cock, you can see that same pathway with the difference of GnRH decrease at the hypothalamus and the FSH and LH from the anterior pituitary, and then there will be decrease in testosterone level, there will be testicular weight reduction, semen volume gets reduced, sperm concentration gets reduced, and ultimately overall the culmination would be in the male, it will be the decreased fertility. So this is the impact of the heat stress on the egg production in particular. You can see that what are the effects. It can decrease the number of egg, it can decrease the size of the egg, and it can decrease the egg weight overall, and the egg shell thickness will be getting reduced, and also the shell weight also can get compromised, and ultimately there will be shell percentage reduction in the egg, and all these things can affect even the quality of the egg also can get altered. So this is what the increased panting under heat stress condition leads to the increased CO2 level, which can have blood pipe available for eggshell mineralization, and also induces increased organic acid availability. All these can affect the calcium available for the birds, because it is very vital for them for the eggshell formation, and it can affect the shell quality as well. And in terms of meat production, it can negatively affect the fat deposition and the meat quality, and the alteration of the meat chemical composition as well as the reduced meat quality in the broilers, and decrease the proportion of breast muscle especially, and they will increase the thigh muscle because they need to orient themselves to avoid the heat stress affecting them. So for that they try to strengthen their thigh muscle and deviating all the, and that is the reason you get generally a reduction in body weight, especially on the breast muscle, and during the heat stress condition the thigh muscle gets more, and then the protein content also would be low. Of course there will be a lot of breed variation, definitely there are various studies in that. And coming to the immune responses, how it affects the first and foremost, they try to reduce the overall organ weight of the lymphoid organs such as the thymus, spleen or lymph nodes like that, and it can affect the hypothalamo pituitary adrenal axis and adrenomedullary axis. Also can affect the antibodies production, immunoglobulin M and immunoglobulin G reduction, and the phagocytosis may get compromised, and there will be increased neutrophil lymphocyte which will be a good indicator for the heat stress, and there will be decreased intraepithelial lymphocyte as well as immunoglobulin, and also there will be other receptors increase which will all like in the lymphocyte, monocyte, macrophage and granulocytes. All these can be a sequelae of event which immune system in the birds, and these are the events that you can say that very vital, that heat stress and the oxidative stress, because the oxidative stress is a part and parcel of when the birds or the animals are subjected to the heat stress condition, and there is the body attempts to maintain its thermal homeostasis, therefore increased level of reactive oxygen species production would be there. To counter that, the animal will be releasing more heat shock in an effort to protect itself from the deleterious cellular effect of the reactive oxygen species. In fact, higher concentration of HSP70 were found in broilers and laying hens exposed to heat stress in an effort to counter this ROS production. And this is what the production laws incurred. Okay, what is those factors which control this production laws, particularly when the birds are subjected to the heat stress? Maximum temperature to which the flock gets exposed, and most importantly the duration of this higher temperature exposure. This is very, very vital, because if it is of very lesser duration, it may not have a serious impact or the repercussions on the body weight gain, but then if it is prolonged, the duration of the exposure is prolonged, then it will have a serious impact. And then the rate of temperature change, how the birds can cope up ability as per the temperature change naturally. And of course, if it is the temperature is culminated with the higher humidity, then the stress level is more intensified. As a result of the relative humidity of the air also is a vital factor which can determine the level of production loss. And it has been grouped under 4 different categories. And the first category, where the green portion says that the animal can be called as the birds can be in very comfortable zone, which is the THA index of 70 degree, especially when the temperature is programmed in degree Fahrenheit. And the second category, which is called alert, where the range of THA is between 70 to 75. And the third category is danger, where the range is between 76 to 81. And in the last, which is emergency, wherein the animal try to lose their inherent ability or all the body reserves in an effort to cope up, that will be lost. So ultimately, the animal would be under serious threat for the death. So that is called emergency. That is called above 81 THI units. If it is, these are the demarcation, and we need to have this chart in each poultry farm, so that we have to manage the effectively that they don't cross the second boundary. So especially in an effort to maintain their production. And this is the temperature humidity index drawback also, because this is a researchable question for all the poultry researchers who are listening to this talk. You can see that the THA index, where the world deals with currently, may not be a full-proofed thermal indices to quantify the heat stress response, principally because it do not take into account the solar radiation and the wind speed. All the cardinal weather variables have to be incorporated if the indices be employed to assess their heat stress status, because this is very vital, because when the air speed is more, the birds or the animals may not feel the pressure at all. So it is very, very important to incorporate all these 4 cardinal weather variables: air temperature, relative humidity, speed and the solar radiation, so that the impact assessment may be more realistic or more meaningful, I can say. And additionally, the THA do not take into account the accumulated heat load index in a day. So that is also very vital, and these things have to be worked out. We have some couple of very good heat load index established at Queensland State University at Australia, wherein they established that incorporating all these 4 cardinal weather variables on equation, of course, those things need to be tested for the poultry. To my knowledge, I think the more research effort needed in that particular aspect in an effort to identify a more appropriate thermal indices to quantify the heat stress response in the birds. And this is what the adaptive mechanism. What all the culmination? Because even the little amount of feed the birds consume, that is also deviated for this pathway. Because here, when an animal is under threat, it is the survival that is more important than the production. So what happens as an adaptive mechanism in the birds, you can see that they are more of a panting species purely, and they can have both the pathway, as I already explained. They try to reduce their feed intake, and it can also directly act on the hypothalamus, and then they can increase the corticotropin releasing hormone production, which in turn can act on the anterior pituitary to increase the ACT and produce the corticosterone in the birds to increase aldosterone as well as corticosterone from the adrenal gland. And what happens in the behavioral, it is the first response the birds exhibit to cope up to the situation. They try to increase the panting mechanism. They try to erecting the wing, which is an important thermoregulatory mechanism in the birds. And then also they reduce the feed intake, and then the resting time also will be prolonged. And what happens in the physiologically, the animal try to increase their respiration rate, their body temperature, as well as their heart rate. And at the thyroid level, you can see that the thyroxine and thyroid would be reduced production, because they try to reduce their metabolic activity in an effort to cope up to the external heat stress. And from the liver, which is the principal metabolic activity controlling hormone, organ, there will be more heat shock protein production as well as the expression of the gene pertaining to the heat shock protein 70, which has been very widely carried out across the globe to identify it as a very good stress marker. So now coming to what are the different adaptive mechanisms the birds they exhibit. Behaviorally, they try to adapt, and then physiologically, they try to alter their variables, and then neuroendocrine adaptation, and blood biochemical adaptation, metabolic adaptation, cellular adaptation, molecular adaptation, and of course, morphological adaptation. These are all the various pathways which you need to work if you're trying to identify important biological marker to quantify heat stress in the birds. You need to work on all these pathways. And that is what we are currently working at NIANP, wherein particularly in the small ruminants taking as a targeted species, we are working on all these pathways to in an effort to quantify reliable biological marker with very high heritable value, so that it could be used in the marker assisted breeding selection. So this is a way forward, because if you ask me as a researcher what is the best methodology to tackle the issue, it is the genetic approach. So we need to resources and the funding for the genetic type of research to identify, especially with the biotechnological advancement that has taken place now in the current scenario, which is making us very efficient to find a solution, particularly from the point of view of developing a thermotolerant varieties of more which can cope up and then also produce optimally in any given agroecological zone. So like behavioral responses, as I already told, that they will spend less time in feeding, they spend less time moving or walking because there won't be many resources, more time drinking and panting, and more time with the wings elevated, and then also they'll be more resting because of the depleted energy resources in them. And then physiologically, the animals' thermoregulatory mechanisms can be controlled by radiation, convection, conduction, and evaporative heat loss, as well as the vasodilation, as most of you would be predominantly knowing what all the mechanisms by which the animal try to cope up. And also structure called air sacs in the birds, and an additional mechanism in birds that promote them the exchange of heat between the body and the environment. During panting, these air sacs promote air circulation on surfaces, contributing to increased gas exchanges with the air, and consequently the evaporative heat loss, wherein they try to maintain their thermal balance. And these are the physiological indicators when the animals are subjected, when the birds are subjected to the heat stress. The first and foremost is the decreased voluntary feed intake, and then the reduced growth as well as the average daily gain, and the atrophy of the thymus as well as bursa in the young birds, enlargement of the anterior pituitary and the adrenal gland, because they need to overwork to produce more corticosterone for the countering the heat stress, and rise of plasma corticosterone as well as the insulin or the glucagon, and synthesis of specific heat shock proteins, and hypoglycemia, because ultimately the glucose are very, very vital for body functioning. Once the depletion in the blood glucose, it causes hypoglycemia, and also there will be increased body temperature. These all could be very good indicators. If you observe in the birds, you can say that they are suffering from the heat stress. And now moving on to the approaches, how to counter the heat stress in the poultry, like the four pathways by which this can be achieved. That is the genetic modification, managemental strategies, and nutritional interventions, and as well as the disease management. The genetic approach primarily will involve genetic selection. So this is vital now. So there are a lot of, I'm having a very good slide on that to propagate to the audience what is the roadmap for. And then there are genetic marker identification studies across the globe currently going. And also apart from that, they are thermotolerant and good producer. They also should be disease resistant. So this is also very vital. When you go for a marker assisted selection, there could be amalgamation of markers involving production and disease resistance, so that the ultimately when you produce a new breed or new strain, they should be able to cope up to the use optimally, and also should be disease resistant. And most importantly, they are all be culminating as the environment response genes or the thermotolerant genes. The managemental strategies are predominantly on the housing management to keep the microclimate in a comfortable condition for the birds to exhibit the normal behavior and the normal productive processes. Of course, sprinklers are very time immemorial. It has been used, and acclimatize the birds for this sprinkling. And then feeding time and space requirement, I'm going to talk in detail in the subsequent slides, and just listing out that feeding at cooler times of the day, preferably early morning and late evening hours, so that time the birds will consume more feed to prevent that feed intake loss during the daytime. And also nutritional interventions, particularly fat supplementation, choice feeding, and protein and amino acid levels should be appropriate, and electrolyte vitamin supplementation, and providing cool drinking water also is an important strategy. And disease management, particularly the vaccination, we have made a tremendous progress, particularly from the poultry sector. We have good vaccination program to control parasitic control, remove the sick birds from the main flock and treat them before leaving them back to the same flock, and separating aged flocks, and then treating them separately before they are using it for the breeding program. And managemental strategies, housing strategies, the proper ventilation, grass cover around the poultry house, and roof should be insulated material, and microclimate modification using circulation fans and sprinklers. These are all the things which are coming under the managemental strategies, particularly the ventilation and the sprinkling system, and having a lighter paint in the roof, and there will be a lot of shaded structure like trees and grass cover around the poultry shed would provide all the important needed microclimate for exhibiting the normal thermoregulatory mechanisms, as well as the production pathways should not be affected. And then do not disturb the bird during the hot part of the time. Prevent the handling of the birds during the hot part of the day. And then also bird handling such as beak trimming, transfer and transport and vaccination should be done in the early morning hours, not during the peak sunshine period, and use foggers and misters to increase the evaporative cooling during the daytime. And also using roof sprinkling during extremely high temperature can remove heat from the roofs and cools the inside house, rather than, because the increasing directly sprinkling the birds could cause of worry because of the increased humidity, because that mixed with the increased temperature could be a very deadly combination to create more magnitude of heat stress. So therefore the sprinkling of roofs can be a very good practical methodology rather than sprinkling the birds. And do not run the feeders during the hottest hours of the day, and adjust the fan thermostat, so that it's very important, because you see that the thermoregulatory mechanism, if you see that indigenous animal, they keep themselves in the night hour, so that in an effort to cope up to the daytime pressure of increased temperature. So when you adjust the thermostat of the they should run continuously during the night and early morning hours. The goal is to maximize the nighttime cooling in the house to prolong the period of moderate temperature in the next day morning. So this is very important to prepare them, to acclimatize them for the daytime pressure of increased temperature. And do not overstock the cages. Allow less air. This allows, because if you overstock, then it will allow the less airflow between the birds and reduce the effectiveness of the ventilation and increasing the heat load in the house. And then also the transportation of the birds, particularly for the culling or for the meat purposes, it has to be done in the early morning hours or at the night time. Place fewer birds per transport crate and have empty crates on the truck to allow space for ventilation around the birds during the movement. And this is the pictorial representation of how the housing management needs to be targeted. You can see that always as a thumb rule, it should be a east-west orientation, because to allow the airflow in the building, it should be in the east-west orientation, and always grow vegetations around, and then the trees or shaded structures should be erected so that they can keep the poultry shed in a very cool place. And also use the open roof ridge, allow hot air to evaporate always. So it is very vital to follow that protocols. And then also paint the roof with white reflective color, reflect the solar radiation, so that it can minimize the microclimate inside. And then also roof insulation or thatching, these materials also can be used to prevent more hotness being maintained inside the poultry shed. And then sufficient roof overhang should be there. This will prevent the sunlight directly affecting the birds. And also there should be some sort of managemental strategies such as foggers, stir fans, and this can be placed at equal, so that they can be very good comfort giving facilities for the birds, so that they can cope up to the temperature quite effectively, and then they can eat, they consume the feed so that they can produce optimally. And also advantage of these fans and mist are also that manure to improve ventilation and remove heat sources also, because they can be otherwise ammonia toxicity can be there. So these all have to be a precautionary measure we need to take within. These are overall keeping them in a very comfortable condition. These points should never be overlooked as far as designing of a poultry shed is concerned. Coming to the nutritional management, high energy feeding can overcome the growth rate depression, and then also high fat content can lower the heat production, and then also growth rate improves and feed utilization improves. And low protein diet and high metabolic energy improves the growth rate and improves meat yield. And supplement them with the limiting amino acids such as methionine and lysine. And vitamin requirements, maintenance of the performance and immune function. And vitamin C, it cannot synthesize during the heat stress, so it can be supplemented at the rate of 1000 milligram per kg diet. Improves the heat resistance and improves the carcass quality. And also it reduces the mortality and acts as an antioxidant, protects them against the oxidative damage, particularly during the reactive oxygen species more production during the heat stress condition. And also vitamin A can alleviate the detrimental effect on the egg production during heat stress. It can be supplemented at the rate unit per kg of diet, and it improves the immunity and protects them against the oxidative damage. It can be called as both vitamin C and vitamin A could be effective antioxidant. And also vitamin E, beneficial egg for the egg production, can be supplemented at the rate of 250 milligram per kg diet for heat stress. Increase feed intake and it improves the egg quality as well as improves the immunity. Act as antioxidant and protects against the oxidative damage. And mineral supplementation, because the electrolyte balance gets altered, so that it is very vital that mineral supplementation, sodium chloride are 0.15 to 0.6%, potassium chloride are sodium bicarbonate. Supplementation in water improves water consumption, increased tolerance to heat stress, and improves the production performance. Probiotic supplementation, of late, lot of researches are happening here, and lactobacillus strain enrich microflora diversity in the chicken and reduce the harmful effect of the heat stress. Particularly providing cool drinking water, the requirement increases during the hot period. As a thumb rule, 0.6% increase in water demand per degree increase in the upper critical temperature in the birds, and 25% more drinking space should be provided during the summer season in particular, and water below body temperature will aid in heat dissipation. So always try to provide cool drinking water around 25 degrees centigrade. During high temperature, demand for drinking water increases. The water to feed consumption usually it is 2:1 at 21 degrees centigrade, but at 38 degrees centigrade it would be 8:1. Ensure sufficient water flow from the drinkers. Providing additional drinkers can increase the water consumption as well. And also cooler water that is below 25 degrees centigrade will help reduce the core temperature and thus reduce the impact of the heat stress on the birds to produce optimally. And also feeding time. If there is enough floor space, extra feeder should be used. Practice feeding at cooler times of the day, particularly early morning and late evening. And laying hens increase their calcium intake during the evening, as eggshells are normally formed during this time. So this is very vital at that time. The supplementations need to be added. Encourage feed consumption during the cooler times of the day. In extreme heat stress, the intensity of light during the, because is a very important practical aspect that people have gone rich dividend by altering the lighting sources. So this is one of the vital managemental practices. I'm having a slide to show wherein you need to switch off the light and where you need to put the light. And in extreme heat stress, lower the intensity of the heat because it can also generate heat within the building, which can cause additional problem for the birds. And thereby the hottest time you should avoid of the day to reduce the bird activity. And intermittent lighting program have always been used successfully in the poultry industry in an effort to cope up to the heat stress to encourage feeding. So like what a lot of latest some technologies are emerging, less stress, more poultry. And this is the Bacillum, a company based at Germany, which we are currently working for the climate chamber for the small ruminants in particular. They are also having such a program for the birds, and this will be a very good information for the audience. Like they use luminous light particularly because they use these luminous lights. Now they emit primarily the blue wavelength lights. So they have identified and they have established on trials from different part of the world that they increases the production by around 2%, 2 to 3% in particular. So in the poultry bird for the meat production. So they got some rich dividend. That is why more yield through particularly effective light. So they can also simulate again because this comes in a tube light format, and they can maintain the advantage here is that one light can equally distribute the intensity of the light within the poultry shed. So there are several advantages, and it is easy for cleaning also. I am having some literature pertaining to this, and that is very interesting. Maybe some of the industrialized who are working here can try this and see that Bacillum oriented lighting natural, it will mimic the natural sunlight without much stress to the animal, so that they can be of less stress and then they can produce more. And this is last part of the discussion, that is disease management, how to manage the diseases. It is very well proved in poultry sector as compared to that of the livestock sector, like other livestock species such as vaccination, parasite control, removing the sick birds, and separating the multi-aged flocks. And vaccination consideration, particularly during the summer season, adjust the amount of medication and volume of water used for water vaccination to reflect the increased water consumption of the flock during the hot weather. And water vaccination during hot weather should ideally be administered within 1 hour, and you spray vaccinating during because bronchitis reactions can occur in birds hyperventilating because of the heat stress. Do not withhold drinking water from the flocks during hot weather. It is best to water vaccinate flocks in the morning, and postpone vaccination during the periods of heat stress whenever possible. And heat stressed birds have decreased immune function and may not respond well to the vaccination. Live vaccines are subject to accelerated deterioration when exposed to high heat. So maintain the refrigeration of live vaccines until the vaccines are administered to the birds. And how to evolve the breeding strategy. This is very, very vital because almost we can say that we have attained the maximum growth potential for the poultry industry. And what are the ways by means we can sustain this? These are the way forward, because particularly with the climate change in place and the projections are quite alarming. A lot of research need to be going in this space to develop new strains, particularly with an amalgamation of the adaptation, production, and disease resistance. We need to identify a lot of biological markers, and genetic modification is crucial, and introducing thermotolerant genes in the marker-assisted breeding and selective breeding strategies to adapt to incorporating these markers so that the birds produced can adapt, reduce, as well as they can be showing extreme resistance for various diseases. And these are all the vital pathway for poultry specialists who are working, particularly the biotechnologists associated with the poultry production. They need to work on this line. These are some of the examples where people have gone rich dividend by identifying these genes, and then they use dwarf gene, naked neck gene, and frizzle gene with very good effect for producing birds with extreme thermotolerance ability. The naked neck gene particularly reduces the feather mass by around 20 to 40%. It culminates in higher growth rate and milk yield. And frizzle gene reduce heat insulation of feathers by curling feathers and reduce their size, and improves body growth during the hot weather. And particularly there are other genes of interest currently off late, HSP7 90 genes. There are more which has been established. I'm just listing as a glimpse what all this. This is the roadmap, particularly if you are a biotechnologist. This slide will be very vital because this is what the roadmap, when especially we have attained the maximum growth of the birds. This is very vital to understand that what is the way forward to further sustain this or fine tune their productive mechanisms. And you identify their thermotolerance level, adaptive mechanism, and what are the species that are sensitive. Go for the marker assisted, means biological marker identification, thermotolerant gene, common environment response gene, genes involved in heat stress response, genes associated with the production loss during heat stress. These all could serve as important biological marker to give us a clue where to concentrate for using them for the marker assisted breeding. Then apply the biotechnological tools such as the good old technologies such as single nucleotide polymorphism, microarray technology, and functional genomics and whole transcriptome analysis. It's advanced if you speak of genome-wide transcriptome studies and genome-wide association studies and next generation sequencing. All these can help us in identification as well as the characterization of candidate genes associated with the heat stress, as well, particularly covering the production, adaptation, as well as the disease resistance. And it can help us then identification of pathway and genetic basis for the selection. And refinement in the existing breeding policies also should happen simultaneously using selective breeding, transgenesis, and marker-assisted selection, which can culminate in the climate resilient poultry production for the country. Disease management, particularly there are two diseases which has a direct affection during the summer season associated with the heat stress, mycotoxicosis and as well as the coccidiosis. The mycotoxicosis, most important cause of mortality during summer. Rapid screening and detection of molds should be taken in feeds. Best control and mycotoxin prevent development of fungi in feedstuffs. Regular inspection of feed stores, reducing storage time, emptying and cleaning feed soils at monthly interval. Detoxification of aflatoxin using activated charcoal, maintaining good standard during harvesting, transportation, and storage will prevent the growth of the molds. Particularly for the coccidiosis, another important cause of mortality during summer, anticoccidial drugs such as nicarbazine and amrolium and medicine should be administered during early hours when environmental temperature is low. Drugs should be administered with the cool, fresh water or feed. Appropriate disinfection program should be also be followed. And this is a very, very important slide to how to manage the poultry birds during the heat stress or the summer season is that it is from the night to 12 a.m. to evening. So you can see that how the temperature should be. First, circle can show from 4 a.m. until 12 p.m. you can allow feeding. There should not be feeding. The feed should be withdrawn particularly from the 12 p.m. to the 4 p.m. Okay, then you can again continue from 4 p.m. until 8 p.m. where you can again provide water and the drinking water, particularly the flush of excessive drinking water with a cool below 25 degrees centigrade should be used predominantly between 12 p.m. to 5 p.m. This is very, very vital. And do not disturb the bird, particularly between the 12 p.m. to 4 p.m. It's very vital. You should not disturb the animal. You can see that yellow color that is called lighting. From 4 a.m. to 6 p.m. you can allow them in continuous lighting, and in the midnight, particularly from the 11 a.m. to 11 p.m. to 1 a.m. you can allow again midnight lighting that will allow the birds for compensate for the little feed intake loss during the summer season, particularly during the afternoon period. That can be compensated when you allow this. And ideally you need to cut off the lighting from 8 p.m. to 11 p.m. and around 2 p.m. Means to the 4 p.m. you need to reduce the you have to cut off the light so that the birds takes rest. These are the good managemental strategy. If you follow, then the poultry birds could compensate for the increased heat load, and then it could be an effective managemental strategy that could be implemented in any form. And these are the way forward adaptation. What are the way forward breeding strategies to evolve tolerant or disease resistant or high producing birds, and strengthening the meteorological services for the early warning system and water resource management and disease surveillance measures, early warning system, and particularly involving more women entrepreneurs for the and strengthening extension services, and most importantly capacity building program, which this is the current activity is also part of such program that wherein we need to train personnels for producing optimal poultry production in the country. And I conclude my talk by saying that given the significance of poultry sector to Indian industry, Indian economy, the fact that climate change poses serious threat to poultry, efforts are needed to counter the adverse impact of environmental stress impacting poultry production. Proper nutritional, housing management and disease management strategies that are cost effective needs to be implemented to sustain productive and reproductive performance of poultry under the changing climate scenario. Some roadmap which has identified that frizzle gene, naked neck gene, dwarf gene, HSP70, HSP90 are considered reliable biological marker to quantify heat stress response in poultry birds, and there should be more intensified research in that line to identify further significant biological markers to use in the breeding program. And genetic improvement by developing suitable breeding program by incorporating biological marker for heat stress in poultry was considered the best strategy and the way forward to develop new strains with higher thermotolerant ability. This is the future perspective. There are students must be sitting over here. They can work on any of these aspects for their programs in the future, and advanced thermal indices incorporating genomics in the and metagenomics in the poultry production and epigenetics involvement, because there are a lot of advancement are taking place, particularly identifying the mechanism of the adaptation or the thermo resilient capacity. These epigenetic mechanisms plays a huge role generation to generation, how they evolve these characteristics to cope to the heat stress condition. They need to be studied in depth so that they can give quantifiable biomarker which can be used in the breeding program, particularly the DNA methylation pattern difference, histone molecule modification. These all can be very good roadmap, and advanced biological marker identification by these type of efforts, and more vaccination program identifying for even for the COVID. Currently people are working around the globe. Such type of efforts are needed to prevent them from occurring in the future. And also climate smart poultry production, this always should never be looked into, because you should have an amalgamation of production, management, nutrition and disease managemental strategies work together to call them as a climate smart poultry production. Well, memory to cherish, as I promised to Dr. Girish Verma in the initial introduction, that he has started a center at Kevasu, CADEX, and now we have started a center at NIANP, Center for Climate Resilient Animal Adaptation Studies, and some of my international collaborators have come, and even few people from the KWAS also have participated in this, cutting across several institutes from India. They have participated on the workshop. Recently we organized a 3-day international workshop in the month of February before we went for the lockdown, wherein we brought in all our international collaborators, and some excellent networking has happened during this period. And it is a new center wherein first of its kind in Southeast Asia, where screening all the birds as well as the small ruminant in particular, because it has a provision for birds, experiment for conducting birds as well as the small ruminant. You can see that it's the uniqueness of this is that in the state there are a few climate chambers wherein the different here is that you can see towards my left, that is called as a thermoneutral zone chamber. You see what happens in the summer season, we always keep the animal in the shed wherein there may be 38 or 37 degrees centigrade, outside environment may be 40, only the 3 degrees, and it is not much. Even that 38 will be stressful for the birds and or the animals. So what happens is that when you wanted to identify biological marker, you need to have good controlled condition. So I have established a thermoneutral zone chamber wherein you will be able to ideally induce the thermoneutral zone. For example, for sheep and goat, currently we have culminated with an experiment wherein we induce them at 24-degree constant, so that they are at maximum comfort. They can sit and eat casually throughout the day, and whereas towards my right, it is called as the heating or cooling chamber, wherein you can alter the temperature from 5 degrees centigrade to 50 degrees centigrade, so that always conduct any type of experiment ranging this. So what is an advantage of this is that you can collaborate internationally, and you can conduct the same temperature devices here, and you can conduct the same program. Any world temperature or humidity can be programmed. The variables are alterable here are the temperature and the humidity. In fact, we are also using that Bacillum light, and we are going to establish that shortly. Then that also will be another factor added to that, so that to provide them the artificial, the natural lighting. using those luminous bulbs, so which can improve their production ability. Some incredible output have been brought. You can see that the animals advantage here is that we don't demarket as in many even in internationally they have demarketed. They cannot see each other. Here it is not the case, because otherwise the animals have to communicate with each other. Otherwise it becomes a social stress. So what happens is that if they can see each other in this setup, and there are individual feeder and waterer, there are feces and urine collection tray individually. So you can conduct such type of experiment. We have had a lot of research facilities. The person, the first is holding the infrared thermal imager, wherein you can program the surface temperature, and we are also having other facilities here for, and there is a video recording facility in this, to can record what is the behavioral adaptive mechanism. So then everything is in place. I would urge, when the COVID pandemic ends, anybody can be coming here and taking such a training and going. We'll be very, very happy to extend this facility for the collaborative research. We can conduct a trial here for all to help you in terms of collaboration. As always, a proud moment, as requested by the publisher, international book on the climate change. That's the reason that we can come and give some tangible output. And over the period of 15 years, it has been a lot of hard work gone into. So we have not wasted anything of that, because we have tried to pull them all together in terms of international book for the Springer and the environmental stress and amelioration livestock production, climate change impact on livestock adaptation and mitigation, and sheep production adapting to the climate change. Of course, we are already in the process of the final one, where we are culminating with the goat production. Goat is the ideal climate animal model. So this is what the progress we have made over the years. It is a proud moment to share with all my teachers, as well as Dr. Girish Verma, who is one of my important mentor as always, for his ever supporting role he has played in my career. So these are the librarians sitting in various institutes. They can be advised to procure this, so that this is very, very important for the way forward to sustain livestock production in the changing climate scenario. These are some of the students' point of view. Some professional affiliation membership is very free of cost, and you can take these. I can also share if you refer back to me. And I'd like to thank especially to Dr. Girish Verma, who have always been my encouraging force. I always respect him from the bottom of my heart for whatever recognition he has given to me, and the cooperation or the encouragement or the support whenever it is needed. And also the other organizers for giving me this golden opportunity to speak before all of you. And this is my email ID and my phone number. I'll be available for any sort of help, particularly for the students. And we are here to help for you for to finding a placement or anything abroad. We have very good international network developed now, and I'll be very, very happy if you are having a career oriented, and you can come and ask us any sort of help, and we'll be very, very happy to do it for you. Thank you so much for the opportunity. Thanks one and all.
Thank you very much. Sejian, you have given a very comprehensive presentation, right from the fundamentals through the mechanisms, means, and even application and advancement of the subject within a span of some 65 minutes or so. It was a very good attempt, and I think it was so beneficial to this one. And actually, one or two small points of clarification I wanted from you, specifically since I am from physiology. So you have indicated the limitation of THI, the temperature humidity index, to account the accumulated heat load of animal. So what is the way out? How do you deal with that? And especially if it is possible by a measurable equation or something like that, so that we can do it by the mechanical devices, even without your intervention. How is it possible? So that if you can have a system in the whole animal shed, it will take care of that one. How do you circumvent that?
That's a very, very pertinent question what you asked, sir, because that's what the stimulating question the students also needed, because this is what the way forward. It directly opens up the gateway for a very good research program for a PhD. As you know that under your guidance, Dr. Prasad did something for the CADEX. They have identified a THI indicator automated. So very easy to use. I'm very impressed, because that is the reason we invited him to present in the international seminar last year here. He came and shared his rich experiences. What is currently it is happening, we are having equation definitely, as you told, that it is called heat load index. It takes into account the temperature from the black globe thermometer. because automatically it also takes the sunshine into account. And in the equation, they have also used my mentor, postdoc mentor, Dr. John Gaugan. You have also undergone that workshop with us at Rajasthan, where you. So, like, he was my postdoc mentor. He is the one who first identified the heat load index, incorporating temperature, humidity, wind velocity, as well as solar radiation. So that is a full proof, and when that can definitely be a very reliable, stress, and they have used it for dairy cattle as well as for the beef cattle. And we need to develop such type of the thing for other species specific thermal indices. Answering your second part of accumulated heat load index. So he also given a solution that in a particular day, for example, the 72 is called the cutoff according to him in that equation. I can share it. I am sorry that I missed that slide. And that equation has a 72 as a accumulated extremely severe heat stress. So they calculate every 1 hour in a day, and then in each hour wherein the accumulated heat load is above 72, it's called extremely severe heat stress. So on each hour you pool, and you can tell the audience that to the researcher that this many number of hours the animals are exposed to the extremely severe heat stress on a particular day. So that is how the equation goes. Daily heat load index, it is called as DHLI.
Now, even before we go to the next question, there is a heavy demand for sharing of your slides. Of course, I was suggesting that it is all depending on your sharing. We cannot share it. So if you are prepared, now of course we are planning to have a compendium at the end of the session, at the end of the 3-day session. So we will be planning, we will be bringing out a compendium. That is there.
I know who is
People will email to me some of your slides. It's up to you.
Yeah, sir, I am open to sharing even the entire presentation. I don't have problem about
that. Great. Okay, thank you.
And the moment I complete, I will share with the organizer my PowerPoint, and she can.
Right. So those who have registered, we will be sending to them. Okay, according to demand. Right. There is no issue. And any further question on this?
Output, particularly for 2% increase in the egg production, have been recorded already. That is considered a good record for NIANP, and that is a very good technology we are using. And coming to the altering the lighting management is a way forward, because we have already reached the summit for the poultry sector. So we are already got the maximum genetic gain. If you ask me as a researcher, so how to sustain this going to be the effort. So in the changing climatic condition, lighting management is going to be very important aspect. So like that, I already mentioned that you need to give a proper rest for the animal only for 4 hours between 11 a.m. to 2 p.m. So like that is the period wherein there is no need for light, and in between there should be in the midnight there is an hour light is needed for them to compensate for the little loss that could be incurred during the daytime for the loss as a result of heat stress. So what happens is that from 4 a.m. until this 11 p.m. you need to have the complete lighting program worked out, and that's what they say that now the lighting incandescent bulbs are always, you can see for us during the winter season, we always wanted to keep the light on because it gives us some sort of warmness. So that also can add to the heat stress problem. So now world is moving towards LED lighting. That is the reason. So luminous is one of the important concept that is the lighting we are propagating for the audience that I have projected. Even I can also share the firm, German firm is placed, supplier is at Bangalore. I can share some of the context with them, because we also are likely to implement that in a short notice. Already they come to the spot and then taken the measurements, everything. So we are working out to do it for sheep and goat. That should definitely work for the poultry as well.
Strategy with the
Sir, another question, sir.
Yes.
Increase in thymosil proportion and
Your voice was breaking, madam. Can you repeat?
Sir, how there is increase in thymosil proportion in first condition?
How there is in?
Yes, sir.
What they are asking?
Increase in thymosil proportion, no, sir. Sir, you have told like that. There is an increase in thymosil proportion in birds in this condition.
Thyroxine.
Thigh muscle, sir. Thigh muscle.
Thigh muscle. Okay. Because there is a lot of break in your voice, I'm not able to hear it. I was misunderstanding your query. That is a good question again. Because why? Because the first mechanism the animal tried to do morphologically to adapt. Okay, they try to develop. That is what the epigenetic changes is all about. Generation to generation interval, the animals or the birds need to adapt to the stress condition. They develop morphologically. If you see that evolution, they have tried to adapt. That is what they say, that the thigh muscle are getting stronger and strengthened because the animal never like to when they are coping, when the breed is very much coping to the heat stress condition, they never try to sit in a place. They try to rework so that they don't to the stressful atmosphere. So one of the primary reason the thigh muscle have to be very strong for that, because even the other muscles or the fat deposition other muscles gets depleted, the thigh muscle will be still intact, because that is an extremely adaptive mechanism. If a bird is a very good thermotolerant breed, you can see that their thigh muscle is very strong and stiff, and it also the muscle mass will be increasing, especially during the summer season, as compared to the other part that is primarily to do with the morphological adaptation.
Okay, sir. Sir, another question.
Yeah.
One second, sir. Could you please give an insight on the nutrigenomics and metagenomics in relation to climate change?
Okay. So, like a very, very important question again, because I'm not an expert who worked here, but I can definitely answer the query. For example, all these genomics tools, advanced biotechnological tools are very, very vital, because that gives us a very sound basic knowledge. See, for any grassroots level knowledge have to be elucidated first to find a permanent solution. See, managemental strategies like amelioration, sprinkling, water, cool drinking water, providing shade, or vitamin mineral mixture, antioxidant supplementation, all these can give only short-term impact. When you wanted to looking for a permanent solution, these are the technologies are in take for us to way forward. So, for example, in metagenomics, you see like you can link metagenomics with everything today, because it is the microbially driven world disease wherein there is influence on almost all. Even for my current experiment, I am working for my postdoctoral, from my PhD student, Dr. Shilpa, who's from Germany here doing with us. She is doing a novel concept of going for the skin metagenomics. So, like how to identify biological marker, you need to target what are the important organ in the animal body which involves in the adaptation, and then you should choose those organ and then go for metagenomic sequencing, so that it will give a clue of what are those microbes that are playing a very vital role for the adaptation event. So that is what we are working. We are particularly implemented that in our study for the rumen, because rumen is a very vital organ for the digestion during the stressful condition, and so they are targeting that, as well as the skin is an important cutaneous evaporative mechanism organ. So we are using these biological material to go for the sequencing in a primary attempt to identify what are those microbial population which is showing a wider diversity, or the more abundant microbes, or what are those pathways that are significantly getting abundant in a particular species or the breed. There are breed differences. We also worked on breed differences for the metagenomics. There are a lot of concepts emerging. You need to target these, because this will give you a vital biological marker. You see, cortisol, corticosterone, all these we can call it as a biological marker. Whether these can be incorporated in the breeding program, there is no answer yet. So you need to identify some genetic markers, particularly which can have a very high heritability value to incorporate in the breeding program. So these are the advanced technologies that could play a role for identification of those important biological markers, which could serve as a way forward.
Okay, sir. Many queries already you discussed in your seminar. People are asking that again and again. So I'm not reading that for you,
Okay.
sir.
Sure.
And some other queries are out of the topic also.
Okay.
Sir, and many people have asked for PPT sharing. Hope you will do that.
Yeah, I will definitely do. Yeah, I will definitely do that. We are here to disseminate science. Dear participants, we are never a scientist. What is there in that? You are not going to do anything with my data or something like that, because we have worked hard to develop this PowerPoint, and I will be very happy if the PowerPoints are being shared among the students and the knowledge can be propagated quite easily through this pictorial representation. I will be very happy to do that. And what I'll do is that after completion of this, I will share the PowerPoint so that the organizing secretary can share it to all the registered participants quite easily.
Very kind
Okay,
of you,
sir.
sir.
Thank you.
Very kind of you. So I think we are coming to the end of the session. So the other doubts or other clarifications or other assistance from this on this topic can be had from Dr. Sejian directly, or we'll be able to give you the relevant slides or the entire slides as he suggested. So we had a very valuable time this time, the first session of the 3-day webinar. And once again, I thank Dr. Sejian, who has shared his basic idea, fundamentals, and his working laboratory conditions and the future plans at the NIANP. I think we are looking forward to have more collaborations with you in that respect, not only in poultry, in other species also. So once again, a word of gratitude to Dr.
Thank you so much,
Sejian
sir.
and all those who have participated and effectively interacted with the speaker. I think we had a nice session. Thank you very much, sir, and thank you
Thank you,
all
sir.
who have participated. Thank you, sir.
Thank you so much.
Dear participants, you will be given with a feedback link today itself. You please fill it and send it back to us. And please fill the correct details in the feedback form so that we can prepare the certificate accordingly. And our next session will be starting by 3 p.m. By Dr. Raj. Please be there to attend the session. And I will thank all the participants and Dr. Sejian and our chairman, Dr. G. Girish Verma, for being here and for making the seminar a successful one. Thank you so much.